Once the pH meter has been turned on and calibrated, the pHs of the two buffer solutions should be taken. To do this, remove the probe from its housing and put it into the pH 7 buffer. The pH of this buffer should read around 7. This is what the screen of the pH meter looks like. When taking the pH reading of any solution, do not write down the pH until the numbers have completely stopped changing. Then write down all significant figures. The probe should be washed with deionized water in between reading the pHs of any two solutions. Next, the pH of the pH 4 buffer should be taken. Put the probe into the pH 4 buffer. The pH should read around 4. Record the pH of the buffer in your notebook to both significant figures. Make a chart to organize and record all of the pH readings along with the names of the solutions tested. Once the pHs of the two buffer solutions has been recorded, you will begin to take the pH of solutions whose pHs are unknown. The solutions tested in this experiment were tap water, deionized water, orange juice, and apple juice.
When classifying acids, the terms strong and weak reference how much that acid ionizes in solution. When an acid is dissolved in water, it donates a proton in the form of a hydrogen ion. A strong acid will ionize completely when dissolved in solution in a non-reversible reaction. A weak acid will only partially ionize into its conjugate base and hydrogen ions. This conjugate base is still reactive in water, so eventually the weak acid and its conjugate base will reach equilibrium in the solution.
A buffer solution is composed of a weak acid and its conjugate base, or a weak base and its conjugate acid. Whenever an acid or a base is added to a buffer solution, the solution will resist changing its pH until the endpoint is reached.
And don't forget, if you clean up your stations, you'll be molecool.